A new formula for pi in 2024. You'd think we would figured out that whole circle ratio thing by now, right?
Right.
I mean, we're already calculating pi out to trillions of digits, so what's the big deal about a few more?
Well, that's what makes this so interesting, you see. It's not really about adding more decimal places. It's about the potential to find new mathematical truths,
Yes.
like stuff that's hidden inside a concept that we thought we already understood.
Okay, so let's unpack this a little bit.
Yeah.
Today we are diving into this blog post from Not Even Wrong, written by Peter Woit. He's a theoretical physicist, and the comment section is really something.
Yeah.
Peter Woit is known for, well, doesn't really mince words, especially when it comes to anything that even sounds like questionable claims in theoretical physics.
Yeah. And he's especially well known for being skeptical of string theory, which is kind of funny because that's exactly the area that these physicists who are claiming this breakthrough in this pi formula are coming from.
And let me tell you, Peter does not hold back his skepticism. I mean, he calls out the press release for this paper. This is a direct quote. He says, "It would be helpful if the people who issued this press release had some sense of shame and had it withdrawn."
Wow, strong words.
Yeah.
But, it's important to remember that even really harsh criticism, it's still a form of engagement, right? Like
Yeah.
in science, it's all about testing the claims that are made, being very rigorous about it, and making sure that they stand up to scrutiny.
Okay, so what are the claims? What did these physicists actually find?
So their paper, which by the way was published in PRL, which is a really prestigious journal, suggests that they've discovered what they call a new and improved formula for pi. And they say it could revolutionize, well, something. It's a bit murky on the specifics.
Murky and potentially overhyped, if we're taking Peter's word for it.
Exactly. And that is where this comment section gets really interesting. Because we have mathematicians and physicists just going head to head on this. And some of them are echoing White's skepticism, while others are saying, well, there might be some value here because this formula might converge faster under certain conditions. And then there's even this whole debate about if this is actually new math or just, kind of like dressing up old ideas in new equations.
It's like finding a new shortcut on your way home from work, but it's really just the same old route with a couple of extra turns thrown in.
It's a great analogy. Yeah, but here's the thing. Even if this new formula doesn't, like, redefine pi as we know it, I think just the fact that it sparked this whole debate is really telling.
So you're saying the controversy itself is actually a good sign?
It's a sign that there is something here worth looking at. Like a lot of times, the most groundbreaking discoveries, they come from questioning assumptions,
Right.
like challenging what everyone thinks is true. I mean, remember, we used to think the Earth was flat.
Okay, so maybe we're not talking like flat earth theory level of paradigm shift here, but I get what you're saying. But before we get too deep into the weeds here, let's bring it back down to earth for a second. For most of us, pi is just that thing that we vaguely remember from geometry class. Like, it's useful for maybe measuring a pi plate or figuring out how much carpet we need for a circular rug. But why should we, the non-physicists, non-mathematicians of the world, care about a new pi formula?
Well, you're right. I mean, for just everyday stuff, like the pi that we all know and love, it's more than good enough, right? But for mathematicians, pi, it's not just a number. It's more like I don't know, like a gateway or something, like a way to reach a deeper understanding.
Right.
It's like, imagine a really complicated clock, like a clockwork mechanism, right? And you might know what the clock does, you know how to read the face, but this new formula, it's like you're suddenly seeing all the gears inside, the springs and everything that makes it work.
So instead of just seeing the end result, the time, we're talking about like really understanding the machinery underneath it.
Exactly. Yeah, it's about uncovering these structures, these hidden structures within mathematics. And even a new formula for something like pi, which we thought, we already knew, it could point to these surprising connections, like between different areas of mathematics that we didn't even realize were connected before.
Like discovering a secret passageway in your house that connects two rooms that you never even knew went together.
Yes, a perfect analogy. That's a great way to put it.
So how does this new formula measure up then? Is it a secret passage or is it just a dead end?
I mean, that is the million-dollar question, right? And honestly, I think the jury's still out on that one.
Yeah.
But but the fact that all of these mathematicians are like seriously debating it, that's a pretty good sign, I'd say. I mean, take Srinivasa Ramanujan, for example. He was this self-taught mathematician from India,
Yeah, I have heard of him.
and he came up with all of these really, really intricate formulas, often without even really having rigorous proofs for them. They just kind of popped into his head.
And didn't he claim that a lot of those formulas were, like, divinely inspired?
He did, which, raised some eyebrows to say the least, right? But the amazing thing is that so many of Ramanujan's formulas, as out there as they seemed to everyone else,
Yeah.
they turned out to be true. They revealed these really deep connections in number theory, connections that honestly nobody had even thought of before.
So you're saying, okay, so this new pi formula, maybe it seems a little out there, but it could still lead to some really important discoveries. It's sort of a don't judge a book by its cover
Yeah.
situation.
Yeah, that's a great way to put it. Exactly. But, we do have to address the elephant in the room here, which is the hype. The press release for this paper, it didn't hold back. They, straight up called it a revolution in mathematics. And, well, that kind of language is definitely going to invite some scrutiny.
Sure, it's like saying you found a new chocolate chip cookie recipe that will solve world hunger. It's a great headline, but you're going to have to back that up.
A perfect analogy. And look, the scientific community, it relies on careful analysis,
Right.
peer review,
Yeah.
not just bold claims, right?
Yeah.
And that's actually what makes those comments on Voigt's blog so interesting.
You mean where everybody's kind of chiming in with their 2 cents about this formula? It's like peer review, but in real time and open to everyone on the internet.
Exactly. For example, we have concerned Indian mathematician who points out how, sometimes these scientific achievements get all tied up in national pride, which can lead to overstating their significance. And then there's Will Orrick, who brings up a really good point. Maybe the authors didn't talk to enough mathematicians before they, put this paper out there for the world to see. It seems like they were so focused on the physics side of things that maybe some important mathematical details slipped through the cracks.
Oh, and we can't forget Timothy Chow, who, well, he keeps it brief, but he basically says, look, yeah, this formula might technically be new, but come on, the significance is totally overblown. Like, this is finding a faster way to boil water when we need a teapot that refills itself.
Exactly. They all make really, really good points. And all of their voices, they add up to a much more balanced and nuanced view of what this paper is actually saying. I mean, this is how science works, right? It's all about having these open discussions, these rigorous debates. And yeah, a little bit of skepticism is never a bad thing.
So it's not just about the results, right? It's about how those results are presented, how they're examined, and how they fit into this larger conversation in the scientific community.
100%. And this whole thing, it really just underscores another crucial part of all of this, the importance of collaboration. Like, physicists and mathematicians, they need to work together.
Because sometimes physicists need mathematicians to tell them that they've just reinvented the wheel, or in this case, recalculated pi, I guess.
Exactly. But here's the thing. Even if this new pi formula, right, let's say, even if it ends up being more of a curiosity than this huge groundbreaking thing, it's already gotten people talking, which I think is valuable in itself. We're having this conversation about physics, about math, about how the public understands science. That's important.
And speaking of the public understanding of science, I did see that the authors of this paper, they actually went on Numberphile and talked about this whole thing. And they addressed some of this criticism. They said that they did talk to mathematicians. They even mentioned speaking with Terence Tao, who is like a rock star in the math world.
Right. And they also tried to put some of the blame on their dean, saying that he was the one who was really pushing for that very attention-grabbing press release.
Oh, so it's a bit of a blame game. But honestly, regardless of who's responsible for all the hype, I think this just brings up an even bigger issue here, which is the whole responsibility of accurately communicating science to the public.
Exactly. Like, do scientists, do they have a responsibility to maybe, I don't know, to kind of pull back the reins a little bit when these claims get a little too exaggerated, even if it might benefit them or their institution?
Right. It's a tough one, and there's no easy answer. But I think one thing is very clear. Being able to tell the difference between real scientific progress and hype, that's more important now than ever, especially in today's world where information just moves so fast. So it kind of feels like you need to be a detective these days just to navigate through all the scientific claims out there, you know?
Yeah, you could say that. But, in this case, even though this whole new pi formula thing might not be the huge revolution that some people were claiming, at least it gave us a chance to, dig into it. And along the way, I think we did uncover some really valuable insights.
Yeah. It's like we went digging for buried treasure, right? But instead of gold, we found some pretty cool fossils. Not a bad consolation prize, I guess, right?
Exactly. And, one of the biggest takeaways for me is it's just this good reminder that even in these areas that we think are totally figured out, there are still new things to be discovered. I mean, pi, we've known about it for, what, thousands of years,
Yeah.
and it can still surprise us.
It really makes you think, doesn't it? It's kind of humbling in a way because we always think we have it all figured out, and then boom, someone comes along with a new formula or a new discovery. I don't know, it just reminds me to stay curious about the world.
Exactly. Exactly. And that curiosity, that's what fuels all those aha moments in science, right? Those
Hmm.
unexpected connections that totally change how we see things. Who knows what other mathematical mysteries are just out there waiting for us to find them if we're just willing to question what we think we already know.
Right. I'm like seriously looking at my old math books differently now.
Yeah.
But okay, so beyond the math itself, we also kind of walked straight into this, well, the whole world of scientific hype and how much it can color our perception of these things.
Yeah, it's a tricky one, isn't it? It's a double-edged sword, really. Like, on one hand, you need a certain amount of enthusiasm, to get people excited about science, to get funding. But on the other hand, if these claims are constantly overblown, I think it makes it really difficult to know what to believe anymore. And it can even end up hurting the credibility of the whole scientific community.
Oh, 100%. It's like that story about the boy who cried wolf. Right. If every new discovery is touted as the next big thing, eventually, people just stop listening.
Right. Exactly. And that's why it's so important for all of us to really think critically about what we hear and what we read. Scientists, journalists, even just people listening to this podcast, right? We all have a responsibility to be a little skeptical.
So don't just read the headline and call it a day. You got to dig a little deeper, look at the
Yeah.
sources, see what the critics are saying. Be your own detective when it comes to evaluating these claims.
Absolutely. Because science, it's not just about the results. It's about the whole process. It's a conversation, really.
Right.
And this whole pi formula saga, as controversial as it might be, it's at least got people talking and debating these really important issues, like how does peer review work? What is the role of hype in communicating science? How do different fields like physics and math intersect?
Not bad for a little old pie, right? I guess the lesson here is you never know where a deep dive will take you. And on that note, this has been an interesting deep dive. Until next time.